Hi folks, I'm going to run through the calculation to work out the degree of hydration. Now it's very similar to our empirical formula calculation, but the first thing you will have to do is to read the question really carefully. So 4 grams of our hydrated copper sulphate, that's the stuff with the water attached, makes 2.56 grams of the anhydrous stuff after it's heated and all the water has been driven off. Now we're going to divide the compound up into the anhydrous copper sulphate and the water. We're told in the question that there's 2.56 grams of the anhydrous stuff and we will have to work out the water. Now you're going to work out the mass of water by taking from the mass of the hydrated salt the 2.56 grams of the anhydrous salt, because the difference has got to be water, and you'll find that that comes out at 1.44 grams. Now, just like empirical formula, once we have those masses, our next step always is to calculate the number of moles. Now, we calculate the number of moles by dividing the mass by the MR of the copper sulphate and the MR of the water. Just a quick reminder about calculating MR. If I were to go for the water, well, I would need my periodic table. I'm looking at the top number. The top number for hydrogen is 1. So 2 times 1, add it to the top number for oxygen, which is 16, and that gives me an MR of 18. Same for the copper sulphate then. If I were to work out the MR of the copper sulphate, I need my periodic table, and remember you'll have one in the exam. You're going to add together copper, which is 64, plus sulphur, its top number is 32, plus 4 of oxygen's top number, and that gives you the MR then for copper sulphate. Now, we're going to divide by the MR to work out the number of moles, and keep your number of moles. Don't round it, because that's going to make a difference when we work out the ratio. So it works out as 0.016 moles of copper sulphate and 0.08 moles of water. Now remember, when we were calculating the empirical formula, we always divide then by the smallest number. So I'm looking at 0.016, I'm looking at 0.08, clearly 0.016 is the smallest number. I'm going to divide 0.016 by 0.016 to find 1. I'm going to divide 0.08 by 0.016 to work out as 5. I've worked out that the degree of hydration is 5. If I wanted to rewrite the formula with the water of crystallization attached, my formula would look like that. Now, if we next calculation in our book then, it's very similar. So it's important to read the question really careful. The following mass measurements were taken when a sample of hydrated aluminium nitrate was heated to constant mass. Now we've got the mass of the evaporating basin, we've got the mass of the basin and the hydrated salt, we've got the mass of the basin and the contents after we've heated it, so that is going to be the basin with the mass of the anhydrous salt. Now, to work out the mass of the anhydrous salt, I'm going to say I need to take my 58.39 and I'm going to take away from that the mass of the basin. If I do that calculation, I'll find that that comes out at 4.26. Then, just like before, to get the mass of water, I need to get the mass of the hydrated salt first, which will be 61.63. Take away the mass of the basin, and that works out at 61.63. Take away 54.13. That works out at 7.5 grams. Now, I take away from that the mass of the anhydrous stuff, so 7.5, take away 4.26, gives me the mass of water at 3.24 grams. And there's our mass of water. Now, just like before, and it's always the same steps, I'm now working out the number of moles. So I am going to divide 4.26 by the MR of the aluminium nitrate, and I'm going to divide 3.24 by the MR of water, which, as we worked out in the last calculation, is 18. The MR of aluminium nitrate, when I add together all the top numbers, is 2.13. This works out then at 0.02 moles of aluminium nitrate and 0.18 moles of water. Dividing across then by the 0.02, the smallest number, I find that my ratio is 1 to 9. I've worked out that there are 9 moles of water. If I were to rewrite the formula then for the hydrated aluminium nitrate, I would find then that the formula is that, and I'm replacing the N in the formula with this number 9. Now these calculations are important for higher tier. It's quite likely that they'll come up. So do spend a wee bit of time looking over and come and see me if you've got any problems.